A mechanical metronome operates at 120 beats per minute, assuming the movement of the metronome is simple harmonic motion with an amplitude of 4.25 centimeters. What is the maximum speed of the moving metronome? Note that the metronome beats twice for each full oscillation. So that's interesting information because when we look at that 120 beats per minute, two of those beats constitutes an oscillation. So that's really 60 oscillations per minute. That's one oscillation per second. So I'm going to interpret that as a frequency of 1 hertz. So hertz as a unit is dimensionally equal to 1 over a second, but you can interpret it as saying the number of oscillations per second, which in this case was 1, and so hence 1 hertz. That means that the angular frequency omega, which is 2 pi f, is really just going to be equal to 2 pi inverse seconds. And this might seem a little weird to write pi like this with a unit in a science class. Maybe a way I could have written this is I could have said, well, f is equal to 1.0 hertz, and then here, if I make a little space, I could have said 2 pi times 1.0 second inverse, that is. So that's a little more sciencey looking, or you could have actually multiplied this out as a decimal and round off. However, we're not at an end result, so I see no reason to do that. So I'm actually totally okay with just saying 2 pi inverse seconds. I'm a little less okay with if somebody said, well, is it 2 pi hertz? Because hertz is associated with frequency, inverse second is associated with angular frequency, even though they are dimensionally equivalent. The formula, though, that we can use for this, and oops, I marked my board there. The formula we'd like to use for maximum speed in an oscillation is the one we just derived, which was amplitude times angular frequency. So the fact that I now have this angular frequency and the amplitude is given as 4.25 centimeters allows me to calculate 4.25 centimeters multiplied by 2 pi inverse seconds. And so then I put that into my calculator, 4.25 times 2 times pi. And then my calculator says 26.70353756. And so at this point, we're going to do what is appropriate for a science class and report a decimal answer that is rounded in an appropriate place and with appropriate units, which in this case would be centimeters per second. So we can check that answer, and there it is, 26.7 centimeters per second.